Welcome back to Let's Clone. My name is Toast, and we are finally back to another classic game clone. This time we'll be making balloon fights. Classic game, NES and arcade. You fly around with some balloons over your head, try to pop the other guy's balloons, and we're going to make the two-player version of that. Starting now. If I remember to do so, in the description there will be a link to the project file in which you will have the sprites for the player with the two balloons. Probably should have thrown the ones with the one balloon, but we'll get to that at another time. And I think just one grass sprite. That's going to be all you need to start out with, and we're going to move on from there. So first up, we're going to need to make a room. Come on. Room. Why that is just... Usually I can just start naming things. Room main. Our room is going to be 320 by 256. And we are going to blow that up on the screen. Visible. If you didn't see, I checked enable view and visible. We're going to match the room size at 256, and then we're going to port it at 640 by 512. It just doubles the size of all the pixels on the screen, makes it a little bit easier to look at. All right, workplace. We've got a room. We're going to make use of two different scripts, at least for now. Possibly only two scripts, but we're going to have a script for our player input, which at function script player input. I need 3 of those at description. Receive input from player. And here we're going to need a key for write is equal to keyboard check. I do that a lot. No, we're not going to do pressed. We're just going to use keyboard check, vk write, but we're going to make sure that we get our underscores in place. That is not what I wanted to do. All right, copy that. We're going to have 3. So for right, for up, and for left. Lowercase. Come on. Right, up, and left. That should be all we need for right now. We're going to make another one to hold our macros. So if you right click, come down to convert to D&D or drag and drop. We're actually not going to use any of the drag and drop necessarily, except for creating macros. We're going to make a gravity, which will be 0.05 float value. All right, we're going to build the map out just a little bit first. You see I already have a player created, but we'll see more about that in a second. I'm going to make an object, grass, and our grass sprite right now is just an 8x8 green square. It will change a lot as we move on with this, but for now it's good. Let me just make sure that the origin is 0, 0. So we have a temporary object for the grass. Come into our game room. Instances. Grassy boy. I actually want to... There we go. Come on. I'm just going to stretch this across the room and make it 16 high. I'm going to take our player. We can actually throw the player into the room now, but there's still a lot we got to do for him. All right, jumping into the player object. Technically, we don't really need a sprite here because we're going to handle all of that in code, but just so we can see it over here, I clicked the wrong guy. I'm going to give him the 2 balloons. Just looks a little better in the resource tree. All right, I've gone through and I've already made all of this part, and my method is I code everything out, I get it to work, I then handwrite it on paper because I don't have a second monitor. I tape that up to the wall and then I code. So I've removed all the code and I've left all the comments to try to make it a little bit easier to predict where we're going with this, as well as giving me an easier time to reference my paper and move back and forth. So, and this should all be in the project folder, project file you can download in the link in the description. We've got a couple different things here. We're going to set first is true is equal, is true, is alive. Wow. Is equal to true. We're going to use this to deactivate the player's ability to control the little balloon fighter. These will all make sense later on though. Start x is equal to x, start y is equal to y. These are for respawnability. And then number of balloons. We're actually not going to get around to using this one today, but we're going to need it, so it's there. I've broken up our movement and our speed variables. I don't really know why, but it kind of makes sense to me. So we have horizontal speed, setting it to 0. This will be what actually holds the speed that we're moving at. Same for our vertical speed. We're going to have a move h for whether or not we are attempting to move horizontally, and a move v for the same thing on the vertical axis. Yep, that seems to be good there. Now we're going to have a couple different speed variables. We're going to have a move speed. I always use a couple different naming conventions, and I didn't decide what one I wanted to do here, so I think we're going to go with this one. Move speed is equal to, what I do, 1.5. We're going to have a speed increment. It's going to give us kind of a climbing velocity as we get to our top speed of 0.1, and a flying speed is equal to -1. 1, 2, 3, 1, 2, 3, perfect. Animation variables, a lot will change later on with this as we get into the next part where we have from 2 to 1 balloon, and we're going to worry about all that later, but for right now we can just go along with this. Anim idle is equal to sprite. Player, we're going to give it idle to balloon. We're going to have an animation for his walk, which is sprite player walking 2 balloons. Animation for his slide, which will be sprite player, oh dang it, slide on again 2 balloons. Animation for flying is going to be sprite player flying. An animation for fall is, you kind of get the point. And then lastly, an animation for death is going to be player death. I like to just space these all out with whatever the longest variable was so they look nice and neat. I think we are all set with our create event. Yeah. I think, oh, nope, not quite yet. We're going to say animation current is equal to, we're going to set that equal to the animation idle for now. It'll be immediately changed, but just giving it a placeholder to be initialized with seems like a good idea in my mind. What was this read? I think I saw that. It's supposed to be a point, not a comma. Step event. As you can see, there's a lot going on. We've got quite a bit to do, although most of these comments are just preceding a single line of code, so it's not going to be quite so bad. We're going to apply the physics. I guess more intuitive to call that apply gravity. This is very common with, I think, it's either Sean Spalding or Beast did a lot of the collision and variable speeds and gravity that I've been using, but I've been using them for years because of those guys. If v speed is less than 10, damn it, see, that's gonna get me with changing my structure around. Less than 10, then v speed is plus equal to our gravity. It's red because we've declared it up here as our script, which I should have named macro. We need to get our information from the player. Apply gravity, get yes. Now, if we want to control the player, that is only going to be if player is alive. Now we're going to come down through all of these and we're going to close that there. Just after the vertical collision, we're going to get to that when we get to that. Now I'm going to see if I can do well with just creating all this as we go through here, not having to always reference my paper, but I'll be looking up a lot. To get our horizontal, we need to set our move h, and that's where we're going to utilize the variables that we've gotten from our player input. So it's going to be key right minus key left. If this is new to you, what it means is, well, come here quick. Key right is going to be set to either 0 or 1. It'll be set to 1 only while the right key is pressed. Same thing for key left, but left key. Here, move H is going to be either right minus left. So if both of them are held, 1 minus 1, 0. If only the right is held, it is a positive 1. If only the left is held, then it is 0 minus 1, negative 1. It's just an easy way to get the correct sign for the direction that we're going. Increase speed with time. This is going to give us a little bit of a crawl. We're not just going to snap to our move speed. And I will resort to the paper here. Increase speed with time. If I'm going to check the absolute value of move H because I want this to test true if it is both positive or negative. And I believe I can do that. I might have to move some things along as we go. So we have HSP plus equals, there we go again, H speed plus equals speed increment times move H. So it's going to give us that 0.1 that we're climbing by multiplied by whatever direction we're trying to go in, either to the right or to the left, and we're going to update our H speed with that. This plus equals is the same as if we were to write HSP or H speed equals H speed plus. Does the exact same thing, but a little bit shorter. Now we need to limit the speed. We need to make sure that we don't just climb infinitely. I'm going to say if, the absolute value, so we don't have to worry about checking both negative and positive, of HSP is greater than move speed. Let me make sure that I'm right on that. I am right on that. If the absolute value of H speed is greater than move speed, then we are going to make H speed. This is going to be a problem. I probably should have just kept with HSP. Oh god damn it. SPD. H speed is equal to move speed multiplied by the sine of move H. No, we don't actually need to know the sign because it's just going to be correct. Now we're going to face our intended direction. What are you whining about? Oh, you're good. Face our intended direction. It's going to be image x scale is equal to move H. Now, one thing I forgot to mention is in all of these players, as long as you haven't clicked around or messed anything up, it should be already set with the correct origin point. We're setting the origin to 823. That is the bottom center, as this denotes. And what that allows us to do is when we walk left, we change the x scale to a -1, it's just going to reverse the sprite around. So by tying our image x scale to our moving direction, it'll just work every time. Image scale, we are booking. Friction with the ground. All right. So here, what I want to do here is when we let go of moving, we don't want to just stop on a dime. In balloon fights, he kind of skids a little bit, and we already have the animation for that, so we need to give him the condition to trigger that animation. So we're going to check to make sure that the ground is 1 pixel beneath us, meaning that we are standing on it. So place meeting at x, y plus 1, object, grass. Oh, what do I do? I want to trust my notes, but I also want to trust the indentation on this. So we're inside alive. I think this is correct. So friction with ground, and this is checking if we are on the ground. So I think these I can tab in a little bit. We're going to get rid of the friction, the on the ground, because we're checking right here if we are on the ground. If we are receiving player input, so we're going to say if the absolute value of move H, just like we've done before. Maybe this way everything was tabbed in. Yeah. I think here. I might have to, we might be fiddling around with some things to figure that out, but that's all right. So if we're receiving input, then we are going to set our walk animation. This is the first time we're going to actually be setting an animation, but from here on it'll be happening somewhat frequently. So we're going to say that anim current is equal to anim walk. Okay, so I think we actually don't need that there. I think that goes here. So we're going to say else. Yeah, this is looking better. Doing it with lining up just the comments is a little bit rough. Now instead of, yeah, I guess walking works, because there's a difference between when we're pressing the button to actually set the walk when we're actually moving. So if we were walking up next to a block and we'd be forcing our H speed to be 0, we technically wouldn't be moving, even though our move H would still be set to 1. So we are going to say if, I think HSP, no, H speed does not equal to 0. This denotes that we are actually moving. This is for if we're walking, which means that this one is, the next one's for if we're idle. Yeah, this is making sense again. So our horizontal speed is some value other than 0, yet we are no longer pressing move H because we are in the else condition to that. So we are still walking, but we've let go. So we're going to apply some friction by using the same speed increment. We're just going to add it in the reverse direction, I guess. So here we can say H speed minus equals speed increment multiplied by move H. So up here we added, right here we added speed increment to our move H, or speed increment multiplied by our move H, and we added that to our horizontal speed. Now we're doing that same calculation, so we're going to be slowing down at the same rate that we were speeding up, but by subtracting it, we're going to be going backwards. Or I guess getting closer to not moving at all. And this is when we are skidding, we're in our slide animation. So we need to set that anim current equal to our anim slide. Semicolon. All right, now we've checked that we are walking here, so else would be when we are, yeah. We've checked that we are walking here, so if we are not walking and we are not pressing any button, then we are just standing still. Nothing else is happening to us. So else we are idle, which we will put here. And really the only thing to do in this situation is to set our idle animation. Anim current is equal to anim idle. And this is all in our check to see if we are else. And I think we can now complete the friction with the ground. Now we're going to check that we are not flying. It doesn't quite make sense right away, but if move, not move vertical. We haven't touched the move vertical variable yet, and we are already checking it, but that doesn't matter because in the first frame that this is run, obviously it's going to be set to 0, so it's going to be false, and then it'll be updated every frame after that. My bad. We here are checking to see if we are touching the ground. This is actually going to be an else if flying, so not touching ground. Same thing. So we could be testing if we are flying, but I just kind of worded it in a weird way and I'm kind of regretting it now. But else if not hitting that, we want to set the fall animation, which is anim current is equal to anim fall. I think we are good. Next, we need to check the input for the flight. That's what I was just talking about with the move V having not been set. So we're going to say that move vertical is equal to, in this case, we only are looking for if it's equal to key up, because key down isn't going to do anything. In balloon fights, there are 2 buttons for flight. One of them you can hold and you continuously flap. The other one you have to tap and go. I don't know if I'm going to put them both in. It's kind of weird with WASDA because having space be an action other than like shoot, have it also be the same thing as up, but a little slower is weird. I don't want to make it shift, and hitting down to float up would be weird. So we're just going to have one continuous. You can fly, or you can just tap that button. A little bit different than how the actual game works, but if you were to map it to a controller, it would make more sense to put in that additional button. And just like our horizontal movement, we want to increment that over time so we can get faster and faster as we go. But first we need to make sure that we are intending to move, which is if move vertical. And here we want to limit our speed. Oh, did that a little bit wrong. I'm going to change up the comments on this a little bit. This one we're going to actually tab over. And then here we're going to add a, flying, just to make it a little bit more in line with how it's going to be. We're going to check if move vertical is currently being set, in which case, oh no, let me plug this guy in. That would have been frustrating. Cool. So if we are intending to fly, now we can increase our speed as we go. So vertical speed, come on, indent for me, plus equals to speed increment multiplied by move vertical. No, it's not. We need to minus equals, because in GameMaker, on the y-axis, positive is going down. So we don't need to worry about the sign of move v, because it's only going to be 1 or 0. It'll never be -1 because we don't have a button to denote going down. So technically it should be -1 because we're trying to go. It's fine, it works. To limit speed, same thing that we did with the horizontal axis. I'm going to say if vertical speed is greater, but this time we're going to do fly speed, then we are going to set vertical speed equal to fly speed. Again, it's a little bit simpler because we don't have to worry about the direction of the move v. Then for the flight animation, we're going to say animation current is equal to animation fly. And we are actually almost done. I know this is a lot of code to write before testing anything, but it would have been kind of weird to break this apart and try to compile when only a couple things were done. So just bear with me. Hopefully I've typed this all correctly so I don't have to do too much time debugging. Now this collision detection, also from Sean Spalding, learned it years ago, memorized it ever since. So it just works really, really well. And I have played around with making my own and they work, but this one's simple, so it's easy to understand. We're going to say if place meeting at x plus h speed, y object, in this case grass. Now this means that in our next position, x plus however many pixels we intend to move, right or left, because we've controlled the negative or positive of that variable, if that collision mask were to be moved by that much, if it overlaps this object that we're trying to compare it to, then that would ring true. So we're not touching it now, but we will be in one more frame if we don't pay attention. So what we're going to do is we're going to utilize a while loop. While is just going to run until this condition is no longer true. And we're going to say while we are not colliding 1 pixel away, not the full, I guess, scale of our horizontal movement, but only the 1 pixel to the side. So we're going to use an exclamation point for not place meeting x plus, and now we only want to check 1 pixel, so we're going to say the sine of horizontal speed, y object grass. Forgot my spaces. While we are not moving, we want to x plus plus. Actually, no, we do not want to do that. We do x plus equals the sine of horizontal speed. We wouldn't have been able to go left if we just did x plus plus. Then we can take our horizontal speed, oh wow, and nullify it. Now I like to immediately apply, the horizontal speed. There we go. A lot of times you'll see people run the collision for their X and then they'll run the collision for their Y and then they'll update both, but that can get you stuck in a lot of corners. So we're gonna ignore it so we don't end up getting stuck in a lot of corners. But we're gonna do the same thing here. If place meeting at X plus, now this time we need to check for the vertical speed. No, my bad. X, Y plus vertical speed. My typing is all over the place. Object grass. Same thing if we are about to collide in the next frame, then we're going to check while we are not colliding at x plus y plus the sine of vertical speed, while we are not colliding 1 pixel away from object grass. then we would like to y plus equals the sine of that very same vertical speed. And lastly, vertical speed equal to 0. You shouldn't be complaining, but no, wait, that was wrong. That shouldn't be there. X plus horizontal speed y, object grass. What are you complaining about? Oh, here, I want the other one. Yeah, so that can close that. Good. Sorry about that. There should be no parentheses around that. The last thing we want to do is set the sprite index equal to whatever our current animation is. Now, since we gave the character a sprite, if we look back into the room, we should see that we have him here. Bring him down to the grass, although he would just float down if he wasn't. And let's cross our fingers to see if it's rare that you type out that much and nothing went wrong. So we'll hope. We should be able to run. We should be able to fly. We should slide with friction to slow down. And yeah, I think that's all we have for right now. Well, dang. Maybe if we pick him up just to see what's happening. Might have just been stuck in the ground because of our placement. Okay. Huh. Oh. That was silly of me. Y plus equals to vertical speed. See? It was the second to last line of code, but it happens. There will always be an error. Come on. Good. Now we can run. If we let go, whoa, that ain't right. But things are kind of working. We can fly. He hits his fall animation, his flapping animation, and then he slides home. Let's figure out what's going on here. So this should be in our friction with ground. If our absolute value of move h mean that we have a 1 or a -1, we're setting animation. Else, meaning that our move h is 0. If our horizontal speed is not 0, meaning that we are moving, h speed minus speed increment times move h. Ha. That was stupid of me. I'm checking move h, but we are in our else condition, meaning that move h has to be 0. I meant to be checking the sign of the horizontal speed. So that is, if you followed mine exactly, line 43, but it's in the walking apply friction via opposite speed increment. 2 mistakes. If there were only 2, I'm pretty stoked. There would typically be a lot more than that. There we are. We can run, skid to a stop. That's perfect. We can fly. This flight seems a little bit fast, but actually it's kind of quick in the game. That seems to be working. What we need to do in the next video is we need to change or add some animations for when we only have one balloon, and also to trigger his death, which we have the animation for, but there's no point putting that in yet. As well as in balloon fights, if you go off the screen to the left, come back, then you will warp around and come through from the other side of the screen. Really easy to do, but we're going to save that for next part. And that would be all for the first part of balloon fights. I just kind of explained what the next goal is, but after that we want to build the environment around it. We're going to add the actual grass sprites, the water sprites, and give ourselves the death conditions for the map. Either in that part or the next part, or just in whatever order I end up doing them. We're going to add a second player and kind of create the score or lives. So we're just going to have the 2-player version of this game. I don't know if I'm going to go through adding the enemies. I might, who knows, figure that out as we go. But this is Les Clone. Thank you for watching, and stick around for the